Hello, this is Garrett Keane with the final video in the solution for the traverse problem. If you look at this example, this is where we finished up the last time. If you remember, at the end of video 5 I asked you to add on these unadjusted partial coordinates, and we ended up with where our values here didn't match the values at the start. Now in practice you wouldn't add on these unadjusted values. What you would do is apply what's known as the Bowditch method to basically adjust these delta E's and delta N's. The adjustments are in these two columns and the final values are in these two columns. These are the values you'd normally use to work out for your partial coordinates, to work out the coordinates of points B, C, D and A. And if you've done it correctly, you should find out that you end up back, if it's a closed traverse, you end up back at point 200, 300 if you start at point 200, 300. Okay, so how does the Bowditch method actually work? Well, if you look at this traverse here, this line here, AB, is 112.635. Our error is 0.167. So if we just consider the delta E's, our total error is 0.1267, so we're 167 millimeters too high. So what we have to do is adjust the four lines in such a way that the total reduction is 167 millimeters. So the total adjustment is 167 millimeters across the four lines. But how do we allocate the error? Do we just divide it by 4? Well, in fact you don't. What you actually do is you adjust it according to the length of each line. So if you look at this line here, 112.635, if you divide that by the total length of the traverse, I have it done over here, you end up here with a percentage of 19.98%, or just 20%. So what that says in effect is that the line there, that the line here, 112.635, is approximately 20% of the overall traverse. So what you will do is take 20% of this error, but it's the negative value of the error, so it's minus 0.167, and we allocate 20% of that to this line here. So we adjust this line here by adding 20% of minus 0.167. So in effect that this partial coordinate will get bigger because you're adding a negative value to a negative value. This green line here, the length of that line is 106.264. That is 18.85% of the overall traverse. So in that case, we will basically get 18.85% of 0.167 minus 0.167, and we add it on to that. So in fact, because that's already negative and we're adding a negative on, we'll also stretch that and make it a bit longer. Because these values are positive, this line here is 164.605. That is equal to 164.605 divided by 563.184. Total length of the traverse is 29.19%, and the last line is approximately 32% of the overall traverse. So what in essence you do is you basically take this error of 167 for the eastings and you distribute it between the four lines according to the length of each line. You do the same thing with the northings, and the formula is actually given here in this sheet here. So if I come over here and zoom it up, what we say here is the correction of delta E of the line, so that is in fact the adjustment that goes into this cell here, is equal to the length of the line divided by the total length of the traverse multiplied by minus DE. So it's 112.635, the length of the line, divided by 563.184, total length of the traverse, multiplied by minus delta E. Well, delta E is down here, it's 100.167. So basically you carry out that calculation, you divide this by that, and multiply the result by minus 0.167, and that result goes in here. You do the same for the northing, but in this time it's the length of the line divided by the total length, multiplied by minus 0.078, and that goes in there. So if you pause the video now, do those two calculations and put them in. I'm about to reveal the result now, and it's minus 0.03, minus 0.016. Okay, now you then come along here. Do I have it done here in plot 7? I haven't done it yet. What you can then do is, if you come here, I've all of them done in that case. So if we come back here, what you can then do is come and do that for the remaining points here. So in this case here, it'll be 106.264 divided by that, and that's multiplied by minus 0.167. That's how you get that error, and you do the same for the northing. So if you do it for lines BC, CD, and DA. Once again, pause the video while you do those calcs, because I'm about to reveal the results now. They are the answers there. And what you can then do to check your answer, sums and checks down here, is you basically add up these 4 delta E's here. You add up the 4 delta N's. So if you do that now, pause the video, add up the delta E's, put it in here, add up the delta N's, put the result in there. I'm going to reveal the results now, so pause it, do the calc, and then I'll reveal the answers. Now you can see here that this is minus 0.166, that's plus 0.167. They're virtually identical. There's a small rounding error because I round each of these to 3 significant figures before I do the next calculation. But if you don't get these values virtually equal, the delta E, the sum of the delta E's and the sum of the small delta E's should be virtually equal for a closed reverse. If that's not the case, it should be the same for even an open reverse. If that's not the case, you've made a mistake in your calculations here. The next thing you need to do then is you come along here and you basically add on your adjustment here to the original value. And so you add the minus 0.033 to the minus 110.832 to get this one. And for this one, you add on the adjustment here to the original value. So if you do those now, pause the video, do the 2 calcs. I'm about to reveal the results. And you can see that this line has been lengthened slightly, this line has been shortened. Okay, pause it again, do for the next 3 lines. I'm about to reveal the result now. Okay. And once again, what you then do for your check is you sum up all the delta E's. I'm sorry, I'll show you that that's actually done here. These are the corrected partial coordinates over here. And then to make sure that you've done it correctly, you have to sum up all your delta E's here and all your delta N's. So pause the video, do those calculations and see what you get in here. Okay, I'm about to show the results. And here you're getting virtually 0 here and 0 there. And that's what you'd expect. If I go back here to the plot, what you're basically saying is, I can't really see it if I zoom in. You're saying here my delta E and my delta N should be equal to 0. Therefore, when I come back around, my A is equal to A prime, and there's no difference between them because you come back onto the same point. So it's 200, 300 in that case. So there's all the values shown there. If I then come here, the final thing you need to do is, as you did before, you add on the delta E, the adjusted partial coordinate, onto your original coordinate for A, and that will give you the coordinate for B. So I want you to do that calculation now. Work out the coordinate here for point B. So it'll be 200 minus the adjusted delta E and 300 plus the adjusted delta N. Okay, pause the video while you're doing those calcs because I'm about to reveal the answer now. And you can see here, I think I showed that here, yep, 89.135 and 320.085. So what you need to do now is do that again for C. So you add on delta E to the original value of E to get the easting for C, and delta N to the original, to the value for northing value for B, and that will give you the coordinate, the northing coordinate of C. And you move around the traverse, adding on the partial coordinates of the next line each time to get the coordinates of the next point. You should find that your A prime now is equal to A when you come back around. So if you do those calculations and work out coordinates for C, D and A. I'm about to reveal the results now. Pause the video and do the calcs if you want, otherwise I'm revealing the answers now. And you can see here that you started at 200 and you've ended up at 200.001, started at 300 on the Nordine and you're at 299.999. So that's more than adequate. So that's it. You normally don't need to work these out. I only did that for illustration purposes. So that is traverse completed. The final thing you do, and what you have to do in your report, is to plot it. So if I go to plot number 9, these are the points here. Now there's no need to plot the easterns and Nordines. All you'd actually plot are the coordinates on graph paper or on AutoCAD or something like that. You wouldn't bother with the partial coordinates. Okay, that's it completed. Thank you very much for listening.